These are the three problems involving the differential calculus.
The first problem is the top of a ladder 10 meters long rests on a vertical wall of residential building while the bottom rests on a horizontal ground. If the top slides down at the rate of 20 meters per minute, how fast is the lower end moves along the ground when the lower end is 8 meters from the wall? The first thing we must do is to draw the figure and label the desired quantities. So this is the illustration of the problem number 1. You can see this is the top of the ladder, which is 10 meters long, rests on a vertical wall of a residential building. So let y will be the distance from the ground to the top of the ladder, while x will be the distance from the bottom of the ladder to the wall. So in this problem, we really want to find the value, or we want to find the derivative of x with respect to t. So since x is given, which is 8 meters, because it is said in the problem that the lower end is 8 meters from the wall. So now, using the Pythagorean theorem, we can describe the relationship between x and y. So this is the formula of Pythagorean theorem. C squared is equals to a squared plus b squared. So in the given, 10 squared is equals to x squared plus y squared. Because as you can see, this is our c, this is our a, and this is our b. So substitution. So in this problem, the result is 100 is equals to x squared plus y squared. Since x and y are function of time, we can differentiate both sides of equation with respect to t and obtain. So what is the derivative of 100? So it is said that any number which has no variable, its derivatives is 0. So 0. What is the next one we must do is to find the derivative of x squared. So the derivative of x squared is 2x. Then add plus the derivative of y squared is 2y. So we can now find that the derivative of x with respect to t is equals to negative y over x multiplied to the derivative of y with respect to t. Since we have now the formula, the derivative of x with respect to t is equal to negative y over x multiplied with derivative of y over with respect to t rather. Since x is given, which is x is equals to 8, so we need to substitute the value of x in the Pythagorean theorem formula, which is 10 squared is equals to x squared plus y squared. So 10 squared is equals to 8 squared plus y squared. So in finding y squared, or the value of y, so y is equals to the square root of 10 squared minus 8 squared. So y is equals to 6. So now the derivative of y with respect to t is equals to negative 20 minutes, because the top slide down at the rate of 20 minutes per minute. 20 meter per minute rather. So because it is slide down, we need to 20 will be negative. So in finding the derivative of x with respect to t, the given formula a while ago is negative y over x multiplied the derivative of y over with respect to t. So the derivative of x with respect to t is equals to negative 6 meters over 8 meters multiplied to negative 20 meter per minute. So the derivative of x with respect to t is equals to 15 meters per minute. Therefore, the ladder moves along the ground at the rate of 15 meters per minute. So the problem number 2 is a man 167.68 cm tall is walking directly away from a lamppost fronting a building at the rate 91.46 cm per second. If the lamp is 8 meters above the ground, find the rate at which his shadow is lightening. So the first thing we do is draw the figure and label the desired quantities. So this is the illustration. So let S will be the length of a man's shadow, and X is the distance of the man from the lamp post. Okay, so it is given in the problem that 8 meters above the ground, if the lamp is 8 meters above the ground, so we need to use centimeter in this problem. So 8, and getting the centimeter of a meter, we need to multiply it by 100. So 8 times 100 is equals to 800 centimeter. By similar triangles, we can find the rate at which the man's shadows is lightening by S over 167.68 is equals to X plus S over 800. So S is equals to 0.27x. As we observe in the given problem, the derivative of x with respect to t is equals to 91.46 cm per second. Because a man is walking directly away from a lamppost fronting a building at a rate of 91.46 cm per second. So, based on the observation, it is the derivative of x with respect to time. So the formula in finding the derivative of s with respect to t is equals to 0.27 multiplied by the derivative of x with respect to t. This should be t. So the derivative of s with respect to t is equals to 0.27 multiplied by 91.46 is equals to 24.69 CPS. The third problem is, a man on a wharf 12 meters above the level of the water is pulling a rope tied to a boat that is rate of 2 meters per minute. How fast is the boat approaching the wharf when there are 20 meters of rope out? Okay, so this is the illustration of the given problem. So a wharf is 12 meters above the level of water. So this is the length. Okay, so the question is, how fast is the boat approaching the level wharf when there are 20 meters of rope out? So, it is said here that R is equals to 20 meters. Yes. Okay, so we want to find the derivative of x with respect to t when R is equals to 20 meters and the derivative of R is equals with respect to t is equals to negative 2 meters per minute. So, using the Pythagorean theorem, we can get r squared is equals to 12 squared plus x squared, which is r squared is equals to 12 squared is equals to 144 plus x squared. Differentiating this with respect to t is so the derivative of r squared is 2r multiply the derivative of r with respect to t is equals to, so the derivative of 144 is absolutely 0, and the derivative of x squared is 2x multiply the derivative of x with respect to the derivative to t. So we can get the formula, the derivative of x with respect to t is equals to r over x multiplied to the derivative of r with respect to t. So this is gonna use this formula. Okay, so the next thing we do is we need to find the value of x. So x is equals to square root of r squared minus 144. So x is equals to, the value of r is 20. So 20 squared minus 144. So x is equals to 256, which is x is equals to 16 meters. Okay, so substituting to this formula. So the formula is the derivative of x with respect to t is equals to, what is our r? So this is the formula, r over x multiplied to the derivative of r with respect to t. So in finding the derivative of x with respect to t, r is 20 meters and x is 16. So the derivative of r with respect to t is negative 2. So the derivative of x with respect to t is equals to negative 2.5 meters per minute. Okay, so notice that the negative signs means x is decreasing.